Hello and welcome to a new module and a new project. This module, our project is to build an app to teach people how to recognize the music notes. In fact, this app also explores the concept of building a game. So our initial problem is what I just mentioned. We need to build an app that trains a person on recognizing the music notes. You can also follow the same steps in this module in building an app that has a game for any type of recognition. In fact, one of my previous classes, a team of students built on this app and made a game for young children on how to recognize the voices of animals. Another team did something on recognizing quotes from movies. So it's the same concept here. I'm using music notes. So we follow the process and explore how we can build an app and define it, and define that initial statement. So our first step is problem formulation. And in the problem formulation, we define the scope. We can do research first, like we did in the previous module, the unit conversion, which I encourage you to do in any of the steps. For the sake of time, I am moving forward here, assuming that I have done my research, but the same type of research we've done for the unit conversion, you need to work on it as well for any type of projects you're working on. So I will write it here, the research, and then the scope, defining the scope of the project. And the scope comes from the research in recognizing what can you do different, and also working with the client, whoever gave you the initial problem, on what exactly are they looking to achieve. So our scope here is to create an app, create a game for a user to recognize different music notes. So how can we test this? So in testing this game, then we can have one main scenario at this iteration. User starts a game and play a full round. With correct answers. So we need to have like a way for in the testing to know if what answer is correct and what answer is not, and try with a full round of correct answers and see if the app will work correctly, and another one, another round with maybe a full round of incorrect answers. And perhaps one third round with a mix of incorrect answers and correct answers. Notice that it is vague. We don't really know much, because we don't really know much about the app yet. As we go through the different iterations, we will learn more about the app, and thus the testing scenarios will become more well defined. The second step is the solution formulation. And in the solution formulation, we follow the model view controller design pattern. And in the model, we're looking for the music notes. So we're looking at a music file that we will have from the user, and we will need to load that music file, and we can think either if we're going to make the files ourselves, or if we have it. In this project, I already have 12 MP3 files. So that will represent the music notes. And then and these files will be shipped or loaded with the app in the app bundle. So we'll need to model the collection of the files or the collection of the notes. And as we learned in the past projects, we can use the NSArray object for that. The music file, how can we model a music file? There is a library and actually part of a framework called the AV Foundation framework. And the file is called the AV audio player file. Not a file, the library. This is a library in the AV Foundation framework that is able to load a music file and give you the ability to play, pause, stop, and control the music file. In addition to the collection of files and the actual music file that we play, we will have to also have some sort of a score and maintain that score. So the score will be a number, maybe a decimal number, so we can use the float type. As we go through the iterations, our understanding will expand and perhaps we'll have some more models, but this is what I can think of right now for a game like this. So let's move to the view. How would the view would look like? And I want to introduce you to one of the tools. I mentioned in the previous project that at this step we need to sketch what the app will look like. And you can do a hand sketch like this. Say, okay, this is the view, and perhaps I'm going to have a button here to start the game. And then it will play a sound, and then the user will have somehow to select which note that they think the sound that was played belonged to, and then the app will give some sort of a response to the user in here. You can do that handwritten as I did, or there are some tools, and one of the tools is called the mybalsamiq, and mybalsamiq.com is a website that allow you to model a mockup or a wireframe for an app or for any other project. So here I went ahead and created a mockup, and if you are in the class at the University of Cincinnati, this will be part of your final project to use that mybalsamiq site, and I will create an account for you. So here you have, I created 5 screens. One screen is the start, and it has a start button and some notes, and it has a link to statistics and a link to a help. So there's a help screen, and the purpose of the help screen is for the user to practice. So there's some instructions on how to play the game, and then some links to the different notes so the user can practice what the sound of each note will look like. And then there is how it will look if it's a correct answer, how it will look if it's an incorrect answer. So if the user start a game and it plays a sound, they can come and click one of those buttons. If it's a correct answer, they are presented with a visual image to indicate it's a correct answer, as well as text that indicates it's a correct answer, and it gives them a status of where they are. So the game will include turns. So once you start a game, you play 4 times, 5 times, 10 times, whatever you want, and that we call this the turns. And so it will say you are now in turn number 3 out of 10 available. And if it's an incorrect answer, it's going to work the same, except that the visual representation, the visual image will be different, and the text will be different as well. When the game is over, the user will see an alert that tell them it's game over and give them the score for this particular game. In addition to the help screen, the user also can see statistics of the game, And the statistics view here is very simple, showing the user 4 statistics: the highest score, lowest score, and the how many games have been played and what was the most recent score. So you can build something like that using the tool like the mybalsamiq.com website or any other tool, or you can do freehand sketch on a piece of paper. This project and this module, as you can see, is a little bit complex than the other ones. There are more than one screens. They all interact together, and there is a concept of game. And as you will see, there is some considerations that we need to keep in mind when we work on the game, especially for the controller. So the view will look at those screens. So we have a main screen. We have the help screen, and we have the statistics screen, and we have the state of the game, which is the start of the game, and then you have the correct answer, the incorrect answer, and the end game. Then we move to the controller. And before we get to the details of every controller, something to discuss about the game. Every game must have a challenge, a mean to present the challenge to the user, and a mean to get user response, and finally evaluate user response. Whether you're doing a text game like the one we're using, or you're doing a video game, or any simple game, single one, two-dimensional, three-dimensional, multiplayer, single player, all of them, if you think about it, the game presents you with a challenge. Then it gives you a mean to respond to the challenge. In my case, in the model I just showed you, the user will click a button to respond, and the challenge is a note. So the user will hear a sound. That's the challenge, to recognize what this sound is. Then the way to present the challenge to the user, here is the sound. They're gonna hear a sound. Then to get the user response, we gonna give the user buttons. Each button has the name of the note, and they click on it to indicate which note they think that sound is. Then the game will evaluate the user response and give the user visual representation of what they have done. This same can go in any other game that you play. You can come up with those 4 different things. So in our game, the challenge is for the user to recognize music note. And then how we gonna present this? The user will hear a sound. Actually, they will hear more than one sound because the game is made in turns. So every game will be multiple turns. Or maybe you can call it either a turn or an attempt. So they're gonna, let's say, 3 turns or 3 attempts. So they will hear one sound, they respond, another one, they respond, a third one, they respond. Then the game is over, and then they get the score. So get the user response. Here the user will click on a button to indicate which note they think was played. And then finally, to evaluate, the game will, and the evaluate the user response is also calculating the user's score. So you can think of what is the score mean for your game. And in fact, you can have the same challenge and alternate different ways to evaluate the user and those factors with the same challenge, and come up with 4 or 5 different variations of a game out of it. So for something like what we're doing, you can do like I'm doing, which is the user, we're gonna score based on correct answer. So we're gonna say here score equal correct answer divided by how many turns or how many attempts. So if we give the user 5 attempts and they got 3 attempts with correct answer, then the score is 3 over 5, or make it as a percentage. You can calculate the score as just accumulated correct answer and see how far they can go. So every time they get a correct answer, it adds, and it can stay with them. You can say, well, I'm going to give the user a time. So the score is a combination of how fast they figured the note. So if they figured the correct answer in 1 second, they have more point than if they figured it in 5 seconds or 7 seconds, or so on. So I'm sure if you let your curiosity evolves and think more about this, you will have many different variations. I just wanted to know that a game, with those 4 factors, you can change them in any way you want and come up with different variations of a game that you wanted to play. So this is the controller and the game that we have here. We have multiple screens, as we mentioned, so each one will have its own view controller, and each one will have some ideas of what you do in there. Finally, the solution implementation. And in the solution implementation, we create our implementation plan. We can also think of the solution architecture. Here, the only consideration is we need the music files in the architecture. So we'll say that music files are added to the app. We call it here resources. So this will be considered as resources with the app that you added. So our iteration plan, we have iteration1, which what we currently in now, in which we plan and define the problem. Then we have iteration2, and in iteration2, I'm gonna start with the help screen. I felt that this is the statistics is dependent on starting a new game. The help screen is kind of independent. It also, we're gonna have to figure out how to play a music note, so it has some challenge in it. So I'll do that in iteration 2. Then in iteration 3, we'll do the game structure, like the start game, how we're gonna do that, the end game, how we're gonna implement the number of turns, and so on. Then in iteration 4, we're gonna actually play a game, like play the sound and evaluate. And then in iteration 5, we're going to do the statistics, calculate the score and build the statistics. And then in iteration 6, we'll do some enhancements, because by that time we would have had like our first run through the game. And then finally in iteration 7, we'll see if there's any additional things we can do, and then we can talk about this at later time. So far we'll just stay with iteration 6 over here. So again, to summarize, we'll build a game that is made out of 3 screens: main screen, help screen, and statistics screen. The main screen is where the user starts a game, and they are gonna hear a sound. They start, each game is made out of turns. In every turn they hear a sound. They respond by clicking one of the buttons that carry the different possibilities or options. It's like a multiple choice kind of thing, and they click on the button to indicate which sound they heard. If it is correct, they get a correct answer, they get a visual image, and if it's incorrect, they get the similar response, and it counts, shows them the count where they are, and when they are done, the number of attempts is over, they get an alert that says game is now over. At that time, they can click on the statistics and they can see the stats, and we will talk about the statistics when we get to that iteration. But I have some thoughts in here in that initial sketch. So that's all for the game. In the next video, we'll start the project with the help screen. Thank you.